Thank you very much. I am really thrilled to be here today. Is that the clicker? Okay, great. So before I get started, I want to wish great luck to all the candidates. Sounds like whoever is lucky enough to be the winners, it sounds like you're going to have a lot of work ahead of you for the next couple of years. I hope you know what you're in for. I joined Broadcom about 6 months ago, and there's just a quick story about why I did that. I had spent a lot of my career in computing, then used in television, computing used in PCs, computing used in servers. In the last 5 years, I was at Hewlett-Packard. And in the last couple of years at Hewlett-Packard, I spent a lot of time on our server storage and networking side, and I was watching what was happening in the kind of data that our customers were starting to collect in their storage systems and in their databases and in their networks. And I realized that more and more and more of that data was coming from devices. A lot of them were consumer devices. Some of them were industrial devices. And I became very interested in this idea of IoT. And the idea that more and more things would have sensors, and that more and more things would collect data, and more things would have to bring that data into big data depositories and repositories, and that somebody was going to have to do something with all that data, and no one quite seemed to know what it was they were going to do with that data, and somehow it was going to be meaningful. So I became very interested in the M2M side of it. And the reason was, I had spent most of my career watching the commercial side of computing. I worked at Lenovo for many years. I was responsible for parts of both the consumer and the commercial business. And it was always the commercial side of computing that really had most of the new innovation in it. As I did the same thing with HP, I ran the HP's PC sales group for the Americas for a number of years. It's a very large business. About half of our revenue came from the commercial customers, only half came from consumer. And even though we were very interested in consumer, it was really the commercial side where the economic power was. It's where the money was. Most consumer PC development is actually funded thanks to all of the growth and revenue in the commercial side. And in the world of IoT, it is likely we're going to see the same economic scenario. As exciting as all the consumer things are we talk about, Fitbits and Nests, the economic growth in IoT is likely to happen in dark matter, in the world of machine-to-machine technology. In the world where sensors will be picking up industrial data, will be used in commercial applications, will be delivered into databases that are collecting information not about individuals, but about industries, looking at that sampling of data across industries, and delivering it back to companies to help them make better decisions. So today's little talk is the first time I'm presenting this idea of dark matter and the economics of massively automated autonomous systems. IoT networks that totally run on their own. Or what some people call M2M. And that would be really good if I advanced that correctly. Page down. Okay. So, what we're going to talk about for the next 30 or 40 minutes have a lot to do with data and analytics and not a lot to do with the silicon that's being used to collect the data, the silicon being used to process the data, and the silicon being used to transmit the data. I don't think I need to give anyone in this room a conversation about Bluetooth or Wi-Fi or Zigbee or 15.4. You're brilliant engineers and you study this often. What I do want to talk about is why I think there is going to be a tremendous amount of growth in the number of sensors, in the number of nodes, in the amount of IoT that is going to be deployed in the commercial space, in M2M. Really, this is all about the automated transmission and of a measurement of some kind, shape, or form, some reading, that's for the singular purpose of creating a larger pool of data across multiple customers and sharing that data back to an individual customer. And if you think about the real big difference between IoT and M2M, one of the differences you'll find out is that IoT will be very personal. I walk into a room, I turn on the lights. IoT will be very much about you. I wear a Fitbit, I want to know what my bio readings are. M2M is going to have a lot more to do with how industries work and finding economies in industries. Let's take a look at what that means and what I mean. The first part of M2M is it's always going to be about grabbing something in the physical world, analog, and moving it into a digital world where it can be processed to go back and change the analog world again. That is going to be one of the big parts, as Matt Hatton says, where the physical world merges with the digital world. What I call massively automated autonomous systems. And the reason I use this term is because the growth in M2M is going to be when there are massive systems, large networks that are connected together, collecting data from a large sample sizes, bring them into big data pools to analyze that big data, much larger populations of data, and to be able to determine outcomes that we should change in a manufacturing environment, in an agricultural environment, or something as intimate as your car. So these are massive systems that has to be automated, it has to be autonomous, and it has to come back to a system or a platform so it can be delivered back to you. So it's all about the data. That is a big difference in M2M versus IoT. IoT is much more about the function, turn the light on, shut the light off. M2M is much more about the data. Now we have examples of this already, and some industries are already starting to do this, and one of the first ones was really these smart meters. And it was a simple economic problem that had to get solved. It was too expensive to go read the meter. And it was, frankly, very unnecessary. Why can't we have a massively automated system to collect the data from all the meters and then look at that data as a larger population of data? So to give you an example of this, if I knew the coffee that all of you had this morning, and the brand that you chose within the zip code you lived in, and I was able to deliver that data back to the companies who have to deliver the coffee to those locations, and I knew which flavor of coffees you liked, I would be much more accurate in what I would deliver. If I had the sample rate of every vending machine in a college campus, or all college campuses, I would know exactly which Coke to deliver, and I don't have to roll a truck that has too much of anything on it just to make sure I don't have too little. And it's with those economics that will drive the distribution of all of those sensors and wireless devices and build all those databases. Because it's in that economics that why we ended up with smart meters first. Now some of that's going to change, and these will eventually be very, very sophisticated systems, and I would argue that in M2M, the other thing that's going to be different is that the companies that are going to drive M2M are not novelty companies. In IoT, we have really enjoyed some new brands. We have enjoyed Fitbit and Nest, who've come out of nowhere. But if we want to talk about commercial building management, it is not likely that's going to come from a company we never heard of before. It is far more likely that that's going to become the massive automation in an autonomous system from a company that already controls that network in an analog form. Companies like Rockwell. Now, how did it actually all start? So I tried to figure that out in preparation for this presentation. What was the first M2M device ever created? What was the first autonomously device that autonomously gathered a piece of data from an analog world, turned it into a piece of digital information, and sent it out? I don't know if it's true, but one of the first ones I found was actually a device that was built about 1968, 1969 by an engineer who was working for Boeing, who was actually trying to look at experimental cell network phones to try to capture the actual ID numbers, as what we now call the SIM numbers from these phones as they worked on the lines. As many of you know, cell networks actually was a concept that was started originally in the late 1950s. It was developed by a set of Canadian engineers. A number of defense contractors tried to commercialize it, including Boeing. And this automatic line identifier is really one of the first M2M devices that was ever created. It actually captured the device, it collected all of the phone numbers that were used across a cell network, and then fed back into the network how much capacity the network would need. An early M2M, commercial M2M device. Today, those M2M devices are going to be found in other places. And to give you an example, one of the projects that's underway right now is trying to figure out how to make airlines safer. The problem with most airline maintenance is the problem happens when the airplane's in the air. The other problem with airline maintenance is it has more to do with the airplane than it has to do with the airline. So if you knew every Boeing 737 that was flying at any given time, and if something happened to one of those planes while it was in flight, a small mechanical concern, it might be valuable for all the other pilots that are flying 737s at that time while they're in the air to know that. Today, we don't have a way to do that. We do not have a massively autonomous, automated system to be able to grab that information, bring it into a database, look at that, find out every plane that's flying, and send a note, be careful, one of the planes up there seeing this, make sure you're not having the same problem. We live in a world where most devices work as independent devices. But the beauty of M2M is when the world can work as a massively autonomous network. Now, there are three companies who tend to be interested in large databases and therefore would like to see large, massively autonomous networks. SAP is in the database business. And as you may know, they have spent a lot of time moving to a new technology called HANA. Basically, memory that's active, an active memory environment versus putting all the data on drives. HANA is their big bet. The basic value of HANA is being able to collect massive amounts of data, process it very quickly, give someone access to it and be able to play it back very quickly or get it back out very quickly. HANA is exactly the kind of database that's one of the things we need to make M2M and to make massively automated autonomous networks work. We're also going to need advances in how we route data around. Because one of the realities of M2M is we can't sit around for latency. In a typical network environment, if I send you an email and it gets to you in 5 seconds or 7 seconds or 10 seconds or even 10 minutes, it probably doesn't matter. The network is actually designed to be latent. That's one of the ways it's efficient. But the problem is if I have to have two machines talk to each other, I may not have the luxury of latency. They may have to happen, that message may have to arrive at exactly a precise moment. It might need priority on the network. Or it may need to have a delivery timetable that's specific. Cisco is, and that group of networking companies are working on it. And then companies like EMC and other storage companies who've been in the news lately are very, very interested in this because we're talking about big data, not just on the scale of us putting it in and we're calling it big data, but imagine how much data you collect when you're doing it autonomously and automatically from tens of thousands and millions of nodes and machines around the world. The industries we will service are the ones we've been servicing forever in the analog world. But it's also been the ones that have been the most challenged in trying to understand how to use technology in a way to improve the efficiency of their industries. And one of those, which is probably the best example of an old traditional industry dying for automation, is farming, agriculture. In the last 50 years, we have gone around the world from small farms to large cooperatives to massive farming. Companies now control hundreds of millions of acres of farming. Yet we know no more about how to farm it today than we did years ago. About 15 years ago, the first GPS-driven combines showed up on farms, where the tractors were really steered by GPS. Farming improved 20% thanks to GPS, just by driving the combine perfectly straight and not overlapping. 20% improvement in yield. 20% improvement in how fast we could bring down seed and how fast we could collect it. And then it stopped. Nothing got better. Farming hasn't improved since. What's about to happen in farming is going to be a massively automated autonomous system, where we're going to be able to read moisture levels, not just at the acre level, but at the sub-parcel level by the square foot level, through affordable nodes that can collect that data and bring that back. One farmer in Iowa can have information about what's happening to a farmer in Kyoto, Japan. Farmers in China today now understand feed prices and understand yield pricing. They understand what the market price is, but they don't necessarily understand the best day to harvest. In fact, this is an industry that's been run more by instinct and experience than it's been run by data. Another example is biomedical. I was at Stanford a few months ago. I was enjoying an afternoon off and listening to a bunch of PhD students talk about their different projects. These are PhD medical students who are all complaining that the biggest challenge they face now is they don't know how to collect all the data they need to collect, and they have to start learning programming languages to figure out what's the best database to use to manage it. Because what's happened in medicine is it's become the field of massively automated autonomous systems collecting data for research. And for those of you who have a Tesla, you experienced this firsthand about a week and a half ago when you woke up one morning and your Tesla had a completely different personality, which was based on data they were gathering for months and months and months about where you drove and how you drove, and use that data to help in building the databases they use for your new automatic autonomous driving system. So this goes from things as wide as farms, as specific as medicine, and as personal as your car. Now, where will these centers be? The architecture of this is going to be pretty basic. You are going to have tons and tons of sensors and nodes. In fact, I would argue that the concept of a sensor and a node is going to change a lot over the next 5 to 10 years. Nodes are going to become very industry specific. Nodes are going to become very application specific. And I think you're going to see a lot of companies come out with nodes for a lot of different industries. We've already seen a big change in wireless. You've seen a lot of talk about 15.4. You've seen a lot of talk about Zigbee. You've seen a lot of talk about other technologies to start to take things like Bluetooth and Wi-Fi to places we haven't been before. And we've recently started talking about cellular for mobile. The concept of what kind of cellular device do we need if that cellular device does not move. The entire cellular phone network was based on the concept that your phone's moving. How do I switch the phone as you're going down a highway? What do we need in a cell phone that never moves? How inexpensively can we make it? What is the value benefit of that? Could you make a node that was a cell device, a Bluetooth device, and a Wi-Fi device, and you put it wherever it was and it was smart enough to know what it needed to use? Could we make a node that was smart enough that if you moved it from point A to point B, it knew that, so that when it gathered data, it did it in a different way? These will be the challenges in those networks. Some of our partners are starting to develop the stack of what that's going to look like. What is the M2M data stack going to look like in the future? Because it may not be the enterprise software data stack we're used to. It'll have many of the same things, but one of the things that is going to be very different is going to be how we deal with connectivity support. Because a lot of this is going to go someplace where there isn't a Wi-Fi or a Bluetooth. And we're going to be talking about extending our networks and our Wi-Fi and Bluetooth reach to places that we've never been extended them to before. Now, I've spoken a lot about M2M at big businesses like Rockwell. But we all live in Silicon Valley, and this is the heartland of the startup. So let's talk about how that might happen in a smaller world. Will there be tools available so individuals can create their own M2M networks? Or can create M2M networks that they can connect to larger networks? Stanford University has the luxury of some of the greatest technology of any medical university in the world. There's lots of small medical universities and schools who would like to be able to tie into that too. Connecting to their network is easy. Collecting the data and participating in being part of a massively automated autonomous system may not be so easy. So I would say that one of the things that I thought was very interesting last week was Amazon Web Services reInvent conference. Now, Amazon Web Services is a rather new phenomenon. It's been around Actually, officially, maybe 8 years, but truly kind of commercially viable for the last 4. They had 19,000 programmers show up at that. Most of those 19,000 were not in consumer applications. Most were in industrial applications who were working for small to mid-sized companies who were collecting data and bringing them into their own cloud application and trying to make them, and trying to figure out how to use that cloud application with other applications. They were trying to actually be part of massively automated autonomous networks. They were part of what I believe will be a huge end-to-end industry that's getting started. And things like Amazon Web Services, products like Our Wicked and our competitors' similar products where development kits are available so you can get onto the web easily and turn a sensor device into a web sourcing machine. You can build an end-to-end network. I think are going to be important ways that smaller companies will be able to get to M2M quickly. Now, there are some parts about this that are amazingly unnatural. Very unnatural. Interestingly, it's not in the collecting the data part. In fact, collecting the data is probably the easiest part of M2M. And bringing it to the databases isn't all that hard either. Creating a big data environment is getting easier and easier. Companies like Cloudera are making that simpler. But what's fascinating is in all of the projects that I have watched, the majority of the ones that have failed because they didn't know what to do with the data once they collected it. They still didn't quite understand how to work with massive amounts of data. And in fact, the second thing was they weren't quite sure how to deal with massive amounts of space and time. The agricultural process is not that we don't know what to collect. It's quite a challenge to collect that over a large area. And once you collect it, it's kind of important to understand what part of that data is important to me as a farmer in my farm versus all farmers in all farms. And parsing that is going to become one of the big parts of M2M. And what is going to drive the solution for some of the collecting problems are probably going to be robotics and drone technology. And actually, it's not so hard to fly a drone. I'd crash one or two, but generally it's not so hard. What is hard is when you can't see the drone. And when you deal with massive environments, like a farm, you're going to be sending drones to places that you can't see it. You'll lose line of sight. Well, in every one of the countries that you represent, the US, China, and all the other countries, most countries have some form of an aviation regulation about not flying things you can't see. So one of the things that we'll see is we'll see challenges in how do I deal with all this data? We're going to see challenges in how do I collect that data over large areas? And we're going to see challenges is how do I package that data so somebody who gets it can really consume it? This is a little bit unnatural. We live in an industry that's really about one person talking to one person. We are going to learn how to be an industry that has massive amounts of input being fed, organized, and sent back to people who are going to be using bigger pieces of data in smaller ways. And to do that, we're probably going to need a new set of IT professionals. We're going to need people who understand how massively automated autonomous systems work, how to build them and deploy them. We're also going to need people who can collect that data and know what to do with it. What's interesting is some of the hottest jobs on LinkedIn right now are all focused around some of these problems. Statistical analysis, middleware integration. These are some of the most sought after roles in the Valley, in our industry. And they're all the kind of technology, the kind of roles we're going to need to build the M2M marketplace. A marketplace for massively automated autonomous systems. What this is going to mean at the end of the day is there'll be nodes everywhere, and they are going to have to be self-aware, self-identified, self-adjust. We will see issues with edge security. So if you think security is a challenge today, when you get to M2M and you're deploying thousands of nodes, all of which have access into the network, that's going to create a new type of security challenge. This is really a service. At the end of the day, IoT is about control, but M2M is about a service. And the companies who provide those services today in the analog world are likely the companies who will provide them in the future. But there will be the need for these fast development tools because there will be smaller companies who want to participate in the massive market, and they're going to have affordable ways to get on board into M2M. And then the projector went off. Ran out of time. Do you want to allow the following program? I think no. Don't you love Microsoft? It just went in there and took over the computer. So, in a way, this is us seeing data in all the world of dark matter. And I would say that that is a little bit of a taste of what I'm thinking about as I'm responsible for the IoT business and the M2M business at Broadcom. Those are some of the things that are on my mind when I think about where I'm deploying engineers, how I'm developing products, how I'm developing partnerships, and what I have my team spending the time. Thank you very much. I hope that was interesting, I thought, for a Saturday afternoon. Something really nice. Oh, we're going to give away. So we're going to give something away so you can be the first